All right, section 74, properties. I'm going to write right on. Properties of logarithms. Okay, so since logarithms were created to solve for variables in the textbook, the properties of logs are related to exponential properties. So you do not need to write the here's why it works, but let's talk through that. So get down our title for the section, and our objective is just to use properties of logs. You don't need to write that, but that's where we're going. Okay, so what I have here is an explanation of the first property that we come to. You don't have to write this, let's just talk through it. So we have two logs given to us, x equals log base b of m, and y equals log base b of n. So two different logs, and we are going to say, the first thing we can do is change the form. So log base b of m equals x, the base is b, the exponent is x, so we get b to the x equals m, and over here we get b to the y equals n. So we get those two things. And if we wanted to multiply m times n, then we would be multiplying b to the x times b to the y. When you multiply powers of the same base, what do you do with the exponents? We add them. So m times n is the same as b to the x plus y. And now that's still an exponential form. We can change the form again to go back to log. Log base b of mn, base is here. It finds an exponent, so the x plus y goes on the right, is equal to x plus y, and way back at the beginning we said x equals log base b of n, and y equals log base b of n. So the log of log base b of mn is the same as log base b of m plus log base b of n. That's the property that we are going to be working with. That is your first log property. If I go too far, then I just do fucking the other word. All right. So our first log property, so you can see, is all based on exponential properties. So let's move on, and you need to write down your log properties. Those are the three that we're going to be working with. And this is what needs to go in here. And the use of these properties is, as always, we can use properties to help us solve equations, change the look of it so that we can then solve for what we're looking for. So what I would like to do on this same page is give a simple example of each of those properties, because they'll get more complicated. So you want to have just a nice, easy one to go back to. And we'll do these with variables because they tend to be easier that way. So we'll have log base 5 of x, y. And here we are going to be illustrating the product property. How can I rewrite this? Sometimes you'll be asked to expand this single log to multiple logs. That means using these properties. So that means that we will have log base 5 of what? X plus log base 5. That's the basic idea. We can, these two log statements are equivalent. All right, and easy enough if we did number 2. Let's say we had log say D. Oh no, not D. E over Q. I purposely did not write one. So what base is that? That is log base 10. You don't have to write it. You can write it if you wish, but it would be acceptable if you just said that is the same as log of P minus log of Q. And then finally, number 3, let's say we had log base r of u to the 6 log base r of u, not times, but of. All right, so the third one is the one that gets the most errors. We need to remember that that property applies when we have u to the 6. It does not apply when we have something like this. Then you cannot bring the 6 down to 1. It only applies when the exponent is on the argument alone, not on the entire log. So the property does not work when we have that.
Are we going to have these like equations about us, or do we have to memorize?
You have to know these numbers. You will not be able to. All right. So now, let's go and look at some of these, combining the properties and using some numbers. So, what is each expression written as a single log? All right, well, multiple logs with subtraction can be rewritten as a single log. What replaces the subtraction? It goes to, well, you know, division. So we get 32 divided by 2. And what is 32 divided by 2?
16.
16. All right. And what is log base 4 of 16 equal to? Here we have to get used to seeing this form. It is 2. So think about saying equals y and then changing the form. 4 to the y equals 16. So y must equal 2. Okay, let's try this next one. We have 6 log base 2 of x plus 5 log base 2 of y. This has multiple properties. Take care of the multiplication property, the constant multiple property first. So let's bring those numbers out in front up as powers. So this is log base 2 of x to the 6 plus log base 2 of y to the 5th. And now I can condense that to a single log. Log base 2 of what? Addition becomes not subtraction, multiplication. So we get x to the 6 times y to the 6. And that's as far as we can go.
No, that's just it.
That's it. You have written that as a single log. Okay? Questions on these two? So you can see how all of these properties are going to start getting combined. And you need to systematically work through the problem to solve them. Try these at your desk. Remember, it needs to be a multiple in front of the log to go up as an exponent. Yes. All right, let's look at that first one. Can somebody tell me how to condense it? Raise your hand, please. I'm going with Tyler S. I know your hand was up. I'm calling on you. So this condenses to log base 4 of 5x times 3x. Addition gets condensed and is replaced with multiplication. So we get log base 4 of, go ahead and multiply that out, 15x to the second x squared, right? That's about as far as we can go with that. Log base 4 is 15x squared. All right. So, Stephen, tell me what to do in B. What should I do first?
You should
to be log base 4 of what? Not a 3. It's to the power. 6 to the second. Nope, I haven't done anything with subtraction. The multiplier comes up as an exponent on the argument because it's going to be log base 4 of 6 squared. We still have minus log base 4 of 9. All right. So what is 6 squared? So we have log base 4 of 36 minus log base 4 of 9. And now I can condense that to 1 by doing log base 4 of what? 36 over 9. And what is 36 over 9? Careful. 4. So we get log base 4 of 4. What is that equal to? So every time I ask this, what does this log equal? You in your head should say 4 to what power equals 4? 4 to what power equals 4? So if I set y over here, I've got 4 to the y equals 4. So what must y equal? 1. All right, please note, on all of these properties, you can only apply these properties if those bases are the same. If this were log base 4 of 5x plus log base 2 of 3x, you could not apply the property. Please make sure you note that. Must have same basis to apply properties. All right, moving on. So now what if I ask you to go the other direction? I'm asking you to expand to multiple logarithms instead of condensing to 1. So when you see division, you think it changes to subtraction. When you see multiplication, it changes to addition. So let's take care of the division first. This is log of 4x, then what? Minus log of y. And what you have to note here is that that is multiplication. Right. Thank you. So we have multiplication 4 times x, so I can expand that as well. That would be log of what? What are the two things that are being multiplied? 4 and x. So log of 4 plus, multiplication becomes addition, plus log of x minus log of y. Give you a little trick. Let's look at that next one, log base 9 of x to the 4th over 729.
Wait, so what, that's just the answer?
That's it. They're asking you to expand, just to use the property to expand to multiple logs. Later on, we may do that to help us solve an equation, but right now we're just practicing the property. All right, so we have, for this one, log base 9 of x to the 4th over 729. Let's take care of the division. Good. You know what? I see that exponent. That can come down in front.
So 4 log minus x minus log minus 27.9.
Yep. All right. So now that 729 can be taken further. So, is 9 raised to any power 729? Get your calculator out. Figure out if that's really true. Times the what? Third. So what is log base 9 of 729? That is just 3. So we have 4 log base 9 of x minus 3. Yeah, Amber?
So I don't, how did you put the 4
The third property, the multiple property, is if we have, when we had log base m of n to the 4th, that 4 can come down in front as 4 log base m of n. Quietly.
then the other one we move the plus over to the X.
We're going the other way.
Oh, to the.
So one way we're, so if you look at the example, quiet those. When we're writing it in single log, we can work that property the other way and move that 2 up here. And when we are going to multiple log, we bring that down in front. Okay, so we're going in opposite direction. All right. Wait, one last thing before you go. To be able to do log base 3 or log base some other number, we have to use what is called the change of base. And you can put this in your notes. The change of base formula. And what that allows us to do is we can say log base 3 or any base of some number is equal to log base 10 of the number divided by log base 10 of 3. So the way that I remember this is, you see that the number sign is higher up than the 3, right? So that tells you which one goes on top. The one that's on top stays on top. So we do log base 10 of the number divided by log base 10 of 3. Your calculator can do log base 10. So if I have to find log base 3 of 250 over 37, then on my calculator, I'm going to do the log button of 250 over 37, say, divided by the log of 3. All right. That's everything for your homework. The homework is on the assignment sheet. It will be checked on Thursday. Bye. Good luck. Good luck with all. Thank you.